Choose the graph of the inequality. Y is greater than the quantity x plus 1 squared minus 9. So before we jump into trying to pick one of these values out of the selected graphs that are available, let's try and first decide a few things about what the graph should look like beforehand. So first off, the shape of the graph. Because we have this square term in here, we're going to have a parabola. Now, it sort of looks like all of these graphs are parabolas, so that maybe isn't the most important feature. But if you look at the different options, we have the vertex of these parabolas at different places. So perhaps we could identify things like the vertex, if it's opening upward or downward, in pieces like that that can help us. So we have a parabola, and the vertex here, if you'll notice, the graph is in vertex form, so I can identify the vertex at -1 and -9. And the leading term coefficient is positive, so it would open upward. And one other thing about the inequality is we have a strictly greater than. And if you'll recall about these inequalities, if you have greater than or less than, that represents exclusion. So you're not including boundary points, and you show that graphically with a dashed line. If it was greater than or equal to, then we would use a solid line because it includes the boundary point. Okay, so that right there gives us a few options that we can at least rule out. So any graph that is using the solid line to draw the curve can be thrown out. So that's not a possibility, and that's not a possibility. So it leaves us these two remaining graphs. And I think we can also rule out B because it has the vertex in the wrong place. And that leaves C really as the only remaining option. However, there is one other thing that may have been a situation, and I'd like to show it to you just in case you aren't sure how to do it. And that's how to make sure you have the shading properly done, because really you could have a parabola that is opening upward, has this vertex, and is dashed. But one other option I'd like to show you is the situation where you may have to choose between shading the inside and the outside of the parabola. And in order to do that, what we would need to do is pick some test value. So like if I chose this as a test value and it turns out that it satisfies the inequality, then that means all the points where that test value is, so the side of the parabola where that test value is, get shaded. Or if that ends up being a false statement, then it's the side of the parabola that is not containing that particular point. Now, the origin is a pretty easy point to use, so I'm going to try that. And all I'm going to do is just plug in the coordinates of the origin to this original equation. So when y is 0 and x is 0, I get 0 is greater than, this becomes 1, because 0 plus 1 squared is just 1. Then minus 9 would be -8. And 0 is greater than -8, so that's a true statement. So that means we would shade the inside of this parabola where this point does occur. So definitely C is the correct option in this case.